grab a coffee, and let's dig down into Boolean operators. This video will be special because we'll dig down to the history of Boolean operators, and for the first guy, which the whole Boolean logic is named after him, George Boole. But before we get to him, you can just get to the technical part very quickly, but you will not have an idea how these dudes in the history has thought and worked so much to deliver the knowledge for this guy who created the Boolean logic. That's why I will dig down into history first. If you stick to this, you will understand a big part of the game, and no one on the whole YouTube will explain it to you with this way because I'm passionate about it. So we'll get back to 380 BC to Aristotle. He's known enough that any regular guy who read a little bit about philosophy will know him. So Aristotle made two main contributions to the logic. I mean, he has done a lot of philosophy for sure, but we are talking in this video about the history of logic. So he contributed two main laws. The first law was the non-contradiction law, and the second one was the law of excluded middle. A simple example to understand the law of non-contradiction is the science of being. Aristotle brought a new way of thinking to the philosophy, which was the science of being. So not physics, not mathematics, the science of being. So he thought you can't be 6 foot tall and 5 foot tall at the same time. So you can't be two things at the same time. You are now in the restaurant, or you are not now in the restaurant. You can't be both. And this is how most of the detectives think about it. They look at the place of the crime and see if the actor of the crime has been at that time of the crime in this place or not. So if not, then it's not he who has done the crime. You see how logic has developed with time? The second law is the law of excluded middle. That means if you have a statement like the earth is round, it can be true or false. So a logical statement is false or true, leaving no middle option. And then after Aristotle, you have a timeline of logicians. So you have these Stoic Logicians, and then the Indian Logicians, Islamic Logicians, Scholastic, the Renaissance thinkers. Then you have the philosophers in the 17th and 18th century. And this whole knowledge was delivered to George Boole, improving with time. So we got Chrysippus, who has made a lot of contribution to the propositional logic. Propositional logic are things like or, not, which are called conjunction, disjunction, negation, implication, equivalence. And probably if you are a computer science student, you will for sure go through these concepts when you are learning the logic. Usually it's called logic and discrete structures, and this subject will go through the propositional logic. Propositional logic is a big subject in computer science and in the logic, generally speaking. So this dude has made a lot of contributions into it. And then you got Cleanthes of Assos. So Cleanthes of Assos formalized the arguments and thought deeply about the rules of valid deductions. And he was another logician from the Stoic school in the Hellenistic period who also contributed to the propositional logic. But for sure, Chrysippus and Cleanthes couldn't do their work without Philo of Megara, who shaped the Stoic logical system and started the thinking process about concept of conditional, like if-then, which was known by Aristotle. Philo of Megara was the friend of Zeno of Citium. Zeno was basically the founder of Stoic school. So he created this bridge for the other philosophers to think about the logic. Not only that, but for sure, he contributed to ethics, physics, and metaphysics. But his school and the bridge he created allowed these other guys, and as you see, Zeno was the friend of Philo who started thinking about the conditionals, which led to Cleanthes and Chrysippus to do these huge contributions to propositional logic. So is it the end of the story? For sure not. I mean, at the same time, on another part of the continent, Indian guys were also thinking about life and thinking about the being. So as you see, Aristotle logic with the propositional logic with the Nyaya school of Indian, who also thought about logic in another way, were happening. So for sure, there were some inspirations from each other, and this is how the logic started to be founded and had some pillars. So the Indian logicians had something which was called the 6 paramanas. The 6 paramanas are the 6 ways of knowing. So you have the perception, which are like the 5 senses we have. Then we have the interference, comparison, postulation, verbal testimony, and non-apprehension. And this was a smart way. I mean, the thing that always inspires me is how they thought about these simple things and gave them terminologies, which led later for these terminologies to be structured, and patterns were built on these to build what we have today. So this is the main book of the Nyaya school, the guy called Gautama. He's very known in Hinduism. Gautama, as you see, this is the volume 1, so he has, as far as I know, 3 volumes of this one, and he's not the only one who contributed to the logic, but this is the main book if you want to go deeply into how the Indian logicians thought back then. And the Hindu schools within selves were making some distinctions. So Nyaya school believed and acknowledged 4 ways of these 6 paramanas. So, and maybe you are thinking, okay, so we got the perception, but what is interference? Whenever there is smoke on a mountain or on a hill, that means there's fire there. And this is an example of interference. So it's a way of thinking. When you see smoke on the hill, that means there is a fire there. You see how logic was developed. And then you have the analogy or comparison, or back then cows were a big thing for the Indians, and you know that probably. So a good example in the book of Nyaya Sutras, this book here. So one person, let's call him Jeffrey, has told his friend that there is a creature called cow. This cow has 4 legs, has 1 head, and it walks on these 4 legs. So the other guy, Daniel, he went in the forests and he saw a creature which is weird and walking on 4 legs too. So he thought about it and compared what he's seeing to what his friend Jeffrey was telling him or trying to tell him. And through comparison, he knew that this creature that I'm seeing now, which is white and black dotted, walking on the 4 legs, is probably a cow. And this is analogy. And so on. I'm not gonna get into each one of these, but as you see, this testimony is really easy to explain. It's basically something prophetic. So if there is a guy, a guru in the Hindu tradition, so the gurus, when they tell you something, and if you can prove that this knowledge is from a guru, and you can prove even that this guy is a guru, then it's a way of knowledge. Not every school accepted this testimony, as you see. And coffee is important. That's logic. If you drink coffee, you will be a better coder. That's logic, man. It's logic by testimony. And I'm the guru here, man. And then you know, it's for sure not the end, man. It's the start one more time. Then we got the Islamic Logicians in the Islamic Golden Age. You have Al-Kindi, Al-Farabi, Avicenna, Al-Ghazali, and each one of these dudes has contributed so much to the logic. So we get started by Al-Kindi. I'm starting by the Al-Kindi because he's called the philosopher of the Arab. So back then, Baghdad, as you know, or maybe you don't know it, was the city of knowledge. So in the whole world, on the whole earth, in the Islamic Golden Age, Baghdad was known as the city of knowledge. Everyone used to visit the city to get some books, to go to the libraries, and it's very known for that. And Al-Kindi translated some of the work of Aristotle. He criticized Aristotle and his work. And he thought, so Aristotle was known for thinking deeply about the being, the metaphysics. So that's why he had a statement in his writings that the existence is a property or accident of objects. So that's existence. Although Al-Kindi criticized that and said that everything that exists possesses existence as its primary characteristics. That means existence is not just a property or attribute of any object or accident of objects. Existence is the main and primary characteristic of an object that's existing, and all the other attributes are secondary. And then you got Al-Farabi. Al-Farabi used to live in Damascus, so in Syria, nowadays Syria, and Damascus was really known for the knowledge back then too. And Al-Farabi was called, and is still called till nowadays, as the second teacher. If you Google now, the second teacher after Aristotle, search it, and you will be surprised. You will be surprised, my friend. Yes, so just as a remark, I'm trying my best to show the cases, but be sure that I'm just showing you the upper level. So we are working now with bird perspective. Every one of these guys wrote books and books and books and contributed so much to the logic and criticized the one before him, and his whole life was about studying. And they were not just like logicians. I mean, if you search for Al-Farabi, you will not see the logician of Islamic time. No. As you see, he's a philosopher and music theorist, father of Islamic Neoplatonism. And if you just search the second teacher after Aristotle, you'll find Al-Farabi. So you can do it yourself to be sure about it. This dude has made huge contributions. So he looked at the Greek philosophy, right? And the Greek logic. He saw that Plato had some abstract forms. And Plato, by the way, is the teacher of Aristotle. And Aristotle had some empirical observations, which is basically experimenting and testing. And Al-Farabi has inserted this bridge between abstract forms and empirical observation. So he brought this logical structure and abstract forms of Plato's, and he added upon it, and he implemented that to the philosophy. And then you got experiment, and then you got above of these experiments that you have and tests that give you some conclusions. You got within the syllogistic reasoning, you got some logical structures that helps you to derive some philosophical truths and conclusions. And for that time, that was a huge thing. And then you got Avicenna. And I mean, you should be really ignorant if you don't know Avicenna. Avicenna, I'm not sure if I can do a presentation about him even, bro. Like, it needs hours and hours just like to make an introduction about Avicenna. But I will try to be as concise as possible. So let's get to the flesh, to the meat of the logic piece that Avicenna contributed to improve the logic, because this video is about the logic. So maybe you know the mortal statement of Aristotle, which is basically, let's just search it because it's much better. So Aristotle mortal statement. The statement is, all men are mortal, Socrates is a man, therefore Socrates is mortal. And this is known as the syllogism of Aristotle. And Avicenna, or Ibn Sina, has made a very similar statement, which is, every human is an animal, and every animal is a living creature, therefore every human is a living creature. That is basically A, so A implements B, and then B implements C, that means A implements C, right? And so Avicenna talked about the positions, which are the reality's mental representations. So you can grab the reality and think about it and make a mental representation of the reality. And that is what he has done in this statement here. Then it's not the end. Avicenna was very known for his theory of existence and essence. So that means if something exists, then it should have some shape and color and so on and attributes. These attributes are the essence. And he differentiated between is this, so is this there, and the other question, which is what is this? So is this and what is this? The existence and the essence. Does it really exist? And if it exists, what is it really? And you answer the question of what is it really by describing the essence of an existing object. And this is the very known table in the model logic for Avicenna. And as you see, he had existing things and non-existing things, right? Which are called existence and non-existence. So under the existence, you had necessary beings and possibly, but not necessary. So long story short, if you go down to the necessary in itself and uncaused, so these are like the things that exist, right? Like things that exist that are necessary be existing. It's a necessary to be existing, and it's uncaused, and it's necessary in respect to all aspects. It must not be a composite of something else, and it must not have a shared nature, and it's unchangeable, right? And Avicenna thought that this is the definition of God. So God is a necessary being, it's uncaused. So if you go to the causes of the being, let's assume of our individual being, you'll go through it and back to the history for the first human and question things to reach the one thing, and this one thing will be not caused, and this is like the one only thing which is not caused, and this is the definition of God in Islam. And then you got here something really interesting, which is regarding the non-existence. So regarding the non-existence, you have some things which are possible but not really there or not existing, and you have the impossible things, right? So for example, a unicorn could exist, but does it really exist? No, it doesn't exist. So the essence of them is possible, like you could have a horse with one horn. So a unicorn could exist, but it doesn't really exist. And these are, and it's a perfect example for the things that are possible to exist, but they don't really exist. Then you got the impossible things. For example, can you imagine a circular rectangle or a rectangular circle? No, man. And this is impossible. So it's not possible to think about, it's not possible to have and to exist, and it doesn't really even exist. And this is how powerful the distinction between the essence and the existence has brought to us. I mean, as I've said, Avicenna needs a presentation on himself, but this should maybe explain or give you more idea what he has done. So he was the earliest logician, who created the earliest formal system for model logic, which is what we've seen before now, right? And then we got for sure another scientists and logicians in the Arabic Islamic world, not particular Arabic, but the Islamic world. And as you see, Al-Ghazali is one of these, Fakhreddin al-Razi, Averroes, which is enriched, known as Averroes in Europe. He lived in Cordoba back then. And all of these contributed not this much, but they contributed really so much to the logic. And these are their pictures. So this is Ibn Taymiyyah, this guy, this dude. And you got Nasruddin at-Tusi. As you see, logic, philosophy, and ethics. They used not to do one single thing. They used to do multiple subjects and were experts on multiple subjects. So man, it's mind-blowing and so inspiring. So let's get to the next school after the Islamic Golden Age. Then you got the Scholastic Philosophers. So Scholastic Philosophers were inspired by Avicenna and Averroes, and not just these, like the Islamic Golden Age philosophers has brought so much to the European time, especially in the Middle Ages, especially in the Scholastic Philosophers, where these philosophers started to translate the Arabic philosophy, which has already translated postulated Aristotle and the Stoic and the Neoplatonic philosophies, and now you got the ball is getting bigger and bigger with time. And these dudes has pushed this ball of knowledge, and as you see, same thing. So you got Thomas Aquinas from Italy. He contributed to the syllogism and made it demonstrative. So he got even deeper into the theory of existence and essence, which our dude Avicenna in the previous slide has formalized. And he got an example. So Thomas Aquinas got an example similar to the mortal statement of Aristotle and similar to the Avicenna statement. But this statement is all mammals are animals, all elephants are mammals, therefore all elephants are animals. You see, took ages to confirm and then confirm and then confirm this logic with time. And then you got another ones. I'm not gonna get into the details here. You can search these dudes, they're very known. And this is the Scholastic Philosophers. You got like guys from Germany, from Scotland, France, England. And then you got the next period, which is then you got the Renaissance thinkers. For example, Francis Bacon, who advocated for more empirical approach to logic. So the experimental approach, like you make an experiment, you got a conclusion from this experiment, and this conclusion is known to be true then. And this is the experimental school. Then you got the 17th and 18th century philosophers and mathematicians. And one of these, and the pillar of these, is the German guy, and every German guy should know this one, and I think they learn it even in school, is Gottfried Wilhelm Leibniz. So this is the German way how to pronounce his name. He developed universal calculus ratiocinator, which is a calculating machine, okay? So what did he do with that? He resolved all valid logical interference. So this dude was a big fan of causality, right? So that means everything has a cause. Everything in life has a cause. And he had a glasses through which he saw life, saw our universe. So he didn't believe in coincidences and things without meanings. So everything has a cause for Leibniz. And he really thought deeply about it and observed around him. And he thought about everything that is happening in a specific way in this moment has a reason why it's happening in this way. So he thought that there are causal structures in the universe, and he noticed the importance of bringing clarity to these causal structures, which he calls the universal laws. And if you know set theory, this dude was even a fan of it. I'm not sure if it was like developed after him or before him, but he described his logic even with sets. So he thought like we have the universe and you got a set of good things that are happening or gonna happen. And he thought that this set is really big, that we should be optimists. We should be optimists because there are enough good things in this world. And like Avicenna, he went through the causality of our beings. The causality of our beings. Went through this hierarchy till he reached the one biggest reason. For him, it's God too. So he was believing in God. And once again, there are much more logicians, philosophers, mathematicians that contributed to logic in history. Then after that, we got George Boole, which the Boolean Logic was named after him. He's an English mathematician and logician, developed what we now call the Boolean Logic, which is basically an essential building block of modern computer science. Which is why we are talking about this dude here. And he got something which is called binary variables and logic operators, which we are going to discover now. So now after knowing the history, you know how important that is. So it's not just understanding 1 and 0, but you know the history. You know how much effort the scientists and mathematicians put into this subject. And let's start now with the more practical part, which is we got the Boolean operators, which we are going to use in JavaScript, right? Now, they are in every single programming language, but as an example, we got JavaScript. So let's assume you got a statement X, which is basically that JavaScript is used for spaceships. It could be true or false, according to law of excluded middle from Aristotle. Then we got another statement Y, which is astronauts know JavaScript. The statements could be true or false. This is an example of a Boolean operator. So the AND is a Boolean operator. So a Boolean operator is that if we have a statement X and Y, then X and Y together should have even a true or false value. And this is like how operators work usually. You got like two statements and then you make something in between them, you use an operation between them, and then you got to know like what is the value of these combined two statements. But now let's focus on the AND operator. So in our case, the AND operator is usually true when all the statements are true. So if you got like X and Y, for example, JavaScript is used for spaceships, and you got astronauts know JavaScript. The only case where X and Y together, XY means X and Y, so XY is true is one when the X is true and the Y is true. If the X is false but the Y is true, then this is false, because AND requires that every single element where the operation is used on should be true for the whole statement to be true. But and is not the only operator. You got or operator. So the or operator is usually true when one of these is true. So if you got the first statement, JavaScript is used for spaceships, is false statement. And then you got another statement, which is astronauts know JavaScript. Let's assume it's a false statement. Then x plus y, which is the first statement or the second statement, is also false because the first one is false and the second one is false. So we need just one statement to be true, so x or y are true. So if the x is false and y is true, then x or y is true. Now, if the astronauts know JavaScript and JavaScript is not used in spaceships, still, if you put an or between these two statements, so x or y will be 1 because it's enough to have one of these true to have the or true. And for sure, like when the x is true and the y is true, then you got like x or y will be true. Long story short, you just need one. So if you got like x or y or z or b, right? Like you got like 100 statements and between them we got or, which is the plus here, right? It's to say that this whole thing is true. You just need like one of these statements is true and then you got the whole thing true. And that's the power of or, usually or operator. So you just need one of these statements true to have the rest true. Then you got a not operator, which basically inverts. So if you got the first statement false, then the negation of it will be true. As you see, it inverts true and false. So let's get a real example. This will help you more to understand these statements. We'll work with numbers now. Numbers help you to understand it because you can tell if the statement is really true or false. That's why it helps you to really understand how this operator works. So let's assume we have a variable. We got a variable on JavaScript. This variable is 2040 and we got a statement x, which is year is smaller than 2000. So this year is smaller than 2000 and we can tell this statement is wrong because it's 2040. It's for sure greater than 2000. And the other statement is year, like this year, we're talking about the variable, is greater than 2030, which is true. So as you see, x is false, y is true. Now think about it for a second. What's the negation of x? Knowing that the x is false itself, what's the negation of it? Well, it will be true. Easy. And this is the table of this operation. So if you got 0, it will be 1, 1 will be 0. So false will be true, true will get you false. Then you got the AND operator. So this is the table of the AND operator. You always need it. You will need it always. You can keep it in mind, put it in your mind. I mean, the best way to put it in your mind is that when you are using AND, every single statement should be true for the whole AND to be true. That's why we just have one true. As you see, everything should be true for the whole thing to be true. I understand like that. It really helps me and it's a very practical way to use it. So now x is false, right? And y is true. So x and y you can tell false and true. So 0 and 1 will get you 0 because as I've said, you have one false statement. That's enough to make the whole AND false. Now for this example with the OR operator, you got x is false or y is true. So the rule that we have in mind that while using the OR operator, one single statement, if one single statement is true, then the whole OR is true. That's why, guess what the value of this one would be? It's true for sure. I mean, if you didn't understand these, please take your time to get this rule into your mind because without this, you can't really dig down into deeper things. Yeah, you need to be able to understand these, you know. Take your time, put these rules in your mind, and because it will be like your bread and water. Like every single day you will do these and you should do them blindly. You should know 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. So you should know that. You should keep it in mind. The same if you are talking about truthy values and falsy values. We talked in JavaScript about truthy values and falsy values. What if you have like a truthy value and a falsy value and you want to have a whole value of that? One truthy value and one falsy value. That means truthy 1 and falsy 0. 1 and 0 is 0. So these statements go with time, but if you understand these operators, the logic is the same. And you will really respect like these logicians that we talked about in this video if you really take the time to understand these operators. And let's now like do one last example, which is not x. So we know that x is false. That means not x according to this example here, which we have proven that if x is false, then not x is true. That means like this one is true. So true and y is already true. So true and true. What's the value of this one? Well, it's true one more time. 1 and 1 is 1. Now I got a challenge for you. This challenge is basically not y or y. Not y or y. Keep in mind that not y is false and y is true. So what will be the value of not y or y? Write it in the comments. And if you write true, then give me the reason why it's true. If you tell me false, then let me know why it's false or why do you think it's false. And do me this favor and understand these in depth because you will use them as a developer. And with that, allow me to finish the video. Like this video if it benefited you. and subscribe to the channel to be a better developer. Here's your Jad. See you in the next video.